Calculate the coordinates of B, the turning point of F. We're given that f of x is equals to minus x squared plus 4x plus 5. So we want the coordinates of B, the turning point. What do we know about the turning point? We know fully well that the gradient at the turning point is equals to 0. So we can find f prime of x, of which this is going to be equals to minus 2x plus 4. And then we equate these to 0, right? So should be easy to see that minus 2x is equals to minus 4, x is equals to 2. That is the x value of B. Now let's go ahead and find the y value of B. So we substitute 2 into f of x, not f prime of x, but actually f of x. So we're going to have minus 2 squared plus 4 multiplied by 2 plus 5. So let me just go ahead and put this in my calculator. Minus 2, and then we square that. The minus is on the outside. I didn't put it inside. Don't worry about that. Plus 5. And then I'm getting the y value to be equals to 9. So the coordinates of B, x is 2, y is 9. Okay, let's take a look at 6.2. So 6.2 show that the equation of the line through A and C is given by g of x is equals to 2x plus 2. Okay, let's take a look at this. G of x. So g of x is a straight line, right? And then the point C is a point of intersection of f and g, which is right here. So this point lies on g of x. Does A also lie on g of x? Let's just go through the entire question statement. So the question says show that the equation of the line through A and C. Okay, so the line passes through A and then it passes through C. In order for us to find the gradient, we have the coordinates of C, which happens to be 3 and 8. So in order for us to find the gradient, we need to some way somehow find the coordinates of A, right? Which we can just factorize f of x. We can just factorize f of x, and then in doing that, we will have what do we call this? We will have the values of A. Unless if there's another way of doing it. Is there another way of doing it? I cannot see an immediate way of doing it. But if there is, we can also explore that way. But here I can see that if I let minus x squared plus 4x plus 5 to be close to 0, I can find the x value of A and the x value of D and be able to substitute it into what do we call this? And substitute it into f of x. Okay, so let's go ahead and see. So here, if we divide both sides by minus 1, we get x squared minus 4x plus 5. No, minus 5. Minus 5 is equals to 0. So x factors of minus 5, when you add, we get minus 4 minus 5 plus 1. This is equals to 0. So x is equals to 5 or x is equals to minus 1. It should be easy to see that x is equals to minus 1 is the x value at A, right? So x is equals to minus 1 is our x value at A. Okay, so there we go. We have A. A has coordinates minus 1 and 0. And C has coordinates 3 and 8. So let's go ahead and find the gradient. y2 minus y1 divided by x2 minus x1. So if we take C as the second point, y2 is gonna be 8, right? And then y1 is 0. And then x2 is going to be 3. x1 is going to be minus 1. So 8 divided by 4, that is 2, right? So we know now that the g of x is equals to 2x plus some c. In order to find c, we can substitute either a or c, right? Let's substitute a. A has coordinates minus 1 and 0. So when x is equals to minus 1, y is 0. So 0 is equals to 2 minus 1 plus c. 2 is equals to c. G of x is equals to 2x plus c. Okay, let me just tell you what the problem I have with this question. We got g of x is equals to 2x plus 2, not c. 2x plus 2. And we are quite happy with that. We are convinced that what we have done is correct. But take a look at this. In the diagram below, the graphs of f of x and g of x, a straight line, are drawn. C is a point of intersection of f and g. E is drawn parallel to the x-axis, and E, a point on f, and H are on G. Right. E, a point on f, and H, oh, okay, a point on G. Okay, I see that. But take a look at A. We are now told that A is an x-intercept, and nothing is being said about D. Are we supposed to just look at it and conclude ourselves that those are x-intercepts? I mean, nothing here in the equation says that they are x-intercepts. But in order to find the equation of g of x, we have to take A as the x-intercept. But it is not said. So do we just look at it and say, oh, well, it's close to the x-axis, so it's the x-intercept? Is that what we're supposed to do? Is that mathematical? No, it is not. More especially if we are always told that, I can see point 8 here on the question paper, diagrams are not necessarily drawn to scale. So why am I now supposed to conclude that A is an x-intercept when I'm not being told? Or when it is not shown in some way, hidden or clear? So, not a fan of 6.2. I don't think it's a good question. I'm criticizing the examiner here. But anyway, so it is 6.2. Let's take a look at 6.3. Calculate the maximum length of EH for F is greater than G. A basic equation that we always see. So EH is going to be F of X as it is at the top minus G of X, which is below it, right? So in place of F of X, we have F of X. What else are we going to have? But anyway, minus X squared plus 4X plus 5. And then we subtract G of X, which is 2X plus 2, okay? And then this is going to give us EH is going to be equals to minus x squared, it does not have a like term, and then plus 4x minus 2x, that is plus 2x plus 5 minus 2, that is plus 3. So this is EH. We are looking for, what are we looking for? We are looking for the maximum length, right? So we can already see that EH is a parabola, which is said it looks like something like this. So essentially, we're just looking for the turning point there. So we can derivate and equate to 0, or we can say x is equals to minus b divided by 2a. We can also do this. It's going to allow us to find the value of x at the turning point. So this is minus 2a is minus 1. So is x equals to 1? It seems like that is the case. And then now let's substitute this value of x into EH. So EH is equals to minus 1 squared plus 2 multiplied by 1 plus 3. So we have, we have minus 1 because the minus is on the outside. So minus 1 plus 2, that is 1 plus 3. And then we get 4. So there we go. It seems like EH is a maximum when it is equals to 4. That is the maximum value of EH. Okay, 6.3. Let's take a look at 6.4. So we need to, think just a bit. 5 marks. Let's see what is happening. Given that K of X is equals to F of X plus M, and it is ultimately equals to minus X squared minus 2mx minus m squared plus 4x plus 4m. That is a lot. Let me erase that and write it again so that it can fit in the screen, because it seems like there's a lot happening here. So K of X is equals to minus x squared minus 2mx minus m squared plus 4x plus 4m plus 5. If I sound animated, I'm high on caffeine, so I'm all over the show now, starting to get tired, but let's keep going. Determine the value of m such that g is a tangent. Determine the value of m such that g is a tangent. So g of x is a tangent. G of x is equals to 2x plus 2. So the first thing that we're going to do here, we're going to say that K of X is equals to G of X That is the first thing that we're gonna do. That is the first thing that we're gonna do. K of x is equals to g of x. Why are we equating these two? Because in order for g of x to be a tangent, you can agree with me that k of x and g of x need to touch, right? But the special condition is that they need to touch only once. So we are gonna address that. First of all, let's just address k of x being equals to g of x, because we know that that needs to be true. So let's go and see what we end up with. So k of x is equals to g of x. What does that give us? Minus x squared. Well, let me just copy k of x already because I have it, because it's quite long. I don't want to rewrite it. So this is k of x, and I want to duplicate it and put it here, and then I equate to g of x, which is 2x plus 2. So 2x plus 2. Okay, so I'm going to take 2x to the left hand side, obviously. So I'm going to have minus x squared minus 2mx, and then minus m squared plus 4x minus 2x, that will be plus 2x, and then plus 4m plus 5 minus 2 plus 3. This is equals to 0 when we take that to that side. Okay, so let's just rewrite this in a more acceptable form. Let me show you what I'm talking about when I say in a more acceptable form. So minus x squared. That is the only thing with x squared here, right? Okay, yeah, it seems. So let's find the things with a coefficient of x. Those are the two. So minus 2mx plus 2x. And let's find, and then here I'm just writing minus m squared plus 4m plus 3 being equals to 0. So this is the equation that we have. This is the equation that we have. We can still, simplify that further. Let's do that. Minus x squared, and then minus, I want to take x as a common factor from these two terms. I want to take x as a common factor. So let me say plus x, and then I'm gonna have minus 2m plus 2, right? And then this right here is just a constant, right? So we have minus plus, let's say plus, minus m squared plus 4m plus 3 being equals to 0. So this is A, this is B, this is C. All right, so we need to find the discriminant of that. We need to find that thing, that delta, which is equals to b squared minus 4ac. Why do we need this delta? Because when this delta is equals to 0, g of x and k of x only touch once. When that thing is equals to 0, they only touch once. That is very important to realize, that when that thing is equals to 0, they only touch once. Okay, so b squared, that is going to be minus 2m plus 2 squared, and then minus 4. A is minus 1, and C is minus m squared plus 4m plus 3. There we go. So minus 2m plus 2 squared, that is going to give us 4m squared minus 8m plus 4. Okay, so I've just solved what is inside the brackets there. Yeah, I'm underlining here so that I can not lose track. And then minus 4 plus multiplied by minus 1, that will be plus 4, right? And then what about these? Okay, that is just that. That is m squared. Well, not m squared, but minus m squared. That is minus m squared plus 4m plus 3. Okay, and then this is equals to 0. So my 4m squared minus 8m plus 4 minus 4m squared plus 4 multiplied by plus 4m plus 8m plus 12 is equals to 0. So 4m squared minus 4m squared, that gives us 0. And then minus 8m plus 8m, that also gives us 0. And then 4 plus 12, that is 16. So we get 16 is equal to 0. Okay, I think the issue might lie here. Okay, because m cannot be 0. Well, it can't be 0 because the question just says determine the value of m. But let's re-evaluate these. Let's take a look at these once more. So, shouldn't have erased that. Let me just erase some of it and not all of it. So let me erase, and then yeah, this right here is this part. This right here is this part. So let me do this part, minus 4ac, right? So I have minus, let me erase this. No, I don't want to erase the entire thing. Let me show you what I want to do. So I want to drag these. And say minus 4ac. So I want to find the 4ac separately, right? So I have minus, and then I have my 4 right here, and then I want to solve that, which is inside the brackets there. So when I solve that, obviously I can start out by multiplying with 4, right? And then not 4 but minus 1. So I'll get 4, and then m squared plus, not plus, but minus 4m. Minus 4m plus 3, right? Plus 3 or minus 3. Minus 3 actually. Minus 3. Okay, so that is minus 3. And then this is equals to 0. So 4m squared, we will get, okay, I'm still solving what is inside the brackets there. So 4m squared minus 8m plus 4 minus what is inside the bracket. Inside the brackets, I have 4m squared plus, not plus, but minus 8. No, 4 multiplied by 4 is 16. So I think that is where the issue was arising. It is 16 minus 16m. Now I see where the problem was. Minus 12. Damn it. Almost lost it there. So 4m squared minus 4m squared, that is 0. And then minus 8m minus 16m. That is going to give us plus 8m. And then plus 4 minus 12. So 4 plus 12, that is 16. This is equals to 0, it seems. So 8m is equals to 16. So m is equals to minus 2. M is equals to minus 2. Okay, I see what the problem was. You know, sometimes you do the right thing, you just make one small algebra mistake and you're gone. But let's test and see if it is actually correct, because I'm going to have people in the comments saying, no, it is not correct, this is the correct way, blah, 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 I did this, I did that. Send us your solution. Don't just give us your opinion, send us your solution. Let's take a look at your work. Right, so k of x will now be equals to, because we are saying that m is minus 2, k of x is going to be equals to minus x squared, right? And then minus 2 minus 2, that is the value of m, x, right here it is, and then minus m squared, so that is minus 2 squared, plus 4x plus 4m, m is minus 2, plus 5. So k of x is equals to minus x squared plus 4x, and then this is going to give us 4, and then we're going to have minus 4 plus 4x minus 8 plus 5. Okay, so kx squared is minus x squared plus minus here plus 8x. So minus 4 minus 8 plus 5, that is minus 7. Minus x squared plus 8x minus 7. So this is k of x, and then g of x is equals to 2x plus 2. Okay, so These two things, they must touch. They must touch once. So how can we prove that they actually touch once? Let's equate them and see if we get one solution. So minus x squared plus 8x minus 7 is equals to 2x plus 2. So minus x squared plus 6x minus 9 is equals to 0. I'm giving myself a very unnecessary headache. Okay, so okay, fine. So x squared minus 6x plus 9 is equals to 0. I just divided both sides by minus 1. So that is mathematically correct. So let's see if the discriminant here is going to have is going to be equals to 0. Okay, so that delta b squared minus 4ac. So b squared, that is minus 6 squared, minus 4, a is 1 and c is 9. So this is 36. And then 9, 18, 36. This is 36 also. So this gives us 0. So the discriminant is actually 0. So I'm quite convinced that we have finally done, we finally determined the correct value of m. Okay, so there we go. Which video do you want me to do next?